comes alive. Who you gonna call when you get on the line? Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERS! 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 If there ain't no curve, there ain't no ball. The globe religion about to fall. We're gonna open your eyes so you can see who you're gonna call if you wanna be free. GLOBEBUSTERS! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERS! GLOBEBUSTERS! GLOBEBUSTERS!
And welcome everybody to GLOBEBUSTERS. We accept the reality of the world with which we're presented. It's as simple as that.
It's as simple as that. Hello, everyone, and welcome to another edition of GLOBEBUSTERS Tech. I'm your host, Zach Good Times for All, and today we're going to be asking what is real while contemplating the sky. There's so many different ancient historical concept of what the sky might be. The Bible goes into depth in a few different places on what they think it might be, and it's really a question I don't think that we can answer in this form, so to say. I think it's a question that we'll all have answered one day, but while we're in these bodies, wearing this thing, I don't know if that's possible, but it's fun contemplating and trying to imagine how the sky can be portrayed the way that it is, to where one person sees it and another person sees it from over here and this and that, and it all kind of works together, but it's still kind of a conundrum at the same time. It's really interesting, and we found some videos on optics that we wanted to share with you, and some new ideas that when you're building a model and trying to put all the pieces together, it's impossible if you don't have all the pieces. You have to have all the pieces to get the model together. Now, are there pieces that are in there that say don't belong there? Very well could be. But the ones you don't have that are needed are crucial to trying to get your model to work. So what we're going to do today is go over some of these not new, but just different concepts that some of us might not be privy to yet. But before we do that, we're going to say hello to the panel. And we'll start off with Miss Karen B. I know she's had a exhausting week. Karen, how are you doing, ma'am?
I'm doing great. Happy to be here.
Awesome. Yeah, if you don't know, Karen had a visitor.
I don't want to.
No? Okay, we're not even going to get into it. Okay. Yeah, it's been a wild week. We'll just say that. And all right, we will move on to Mr. Kyle Adams. Kyle, how are you doing today, sir?
Doing well. I've been up to all kinds of stuff. It's just kind of one battle after another. I finally got around to confronting Jaron about some of his anti-flat Earth content that he's been making, and so it's kind of been waiting to happen. Was I respectful enough? I don't know if you got to see that.
Yeah, I didn't watch it yet.
Okay,
I'm having trouble with the whole Jaron thing.
Yeah.
Kind of, it just hurts,
Yeah.
I'm not ready yet to start looking into what he's saying and this and that. I don't even want to see some of it. I know I don't.
Yeah.
So
It kind of
that's where I'm at right now.
What? Sorry, say again. I
Oh,
didn't
I
hear
just
that.
said that's where I'm at right now.
Oh, okay.
Yeah.
Yeah. It was kind of shocking to me because he's repeating back some of Simon Dan's arguments that he made years ago. I was like, what's up with that? Like,
What
where
I've
were
been
you the
hearing.
first time he brought these up? Like, we've addressed these things. This isn't new information by any means. And yeah, we've addressed them a long time ago. So I'm just kind of like bringing that up and kind of literally quoting Simon Dan and showing it like the side by side and then just kind of addressing him. And these are like really basic, easy things to address. And so just what happened to him? And so he actually did respond to me, just kind of in the chats, and you just don't understand. I'm like, what? And it's like, it's all about left and right. And I'm like, I specifically addressed that in the video, and I haven't really heard from him since then. But yeah, I'm kind of, there's a lot more he's presented, and I do want to get to a lot more of that down the road. I just kind of picked the easiest one to tackle and got that one out of the way first, and yeah, work on other points that he's brought up later.
So are you like taking videos that he did and addressing the points, or are you addressing
Yeah.
him one-on-one? You're doing that, and then he was in the chat just giving opinions on it, or
He just made one comment in just kind of in the comment section, just on the YouTube video, and that was it. It's just, you just don't understand. Of like, I directly quoted everything you said, and I kind of stuck on that. And then he tried to shift it to one of the other points. I'm like, okay. So he made, like, in the video I was reviewing, it was like 8 different points against the flat Earth, and so I picked number 3 because he had it all bulleted out, and I just focused on number 3, and then what he said in there, and then he tried to shift it over to point 4. Of like, okay, I'm just focusing on point 3 here. Why are you shifting over here to point 4? But I don't know. But I'll address those other points later. Point 3 was just the easiest one to tackle out of all of them.
Well,
No,
you're
and
very
then-
good at having conversations, so
Yeah, I'm trying to keep it as respectful as I can. And so,
Mhm.
yeah, that's kind
and I
of
imagine yes, you're taking on the topics and not the person, and doing
Yes.
it respectfully.
Yeah.
So yeah, that's well done.
Yeah,
Yeah, I
that's
have.
my
I'm
take.
I'm like Zach. I'm kind of heartbroken by it
Yeah.
all, and
The last thing I want to do is push him farther away. I want to make sure that he still feels loved and appreciated, because he's put
Mhm.
so many great arguments for us in the past, and I just want to
So
treasure
much.
those up and say, do you remember that time you brought up this argument? Because I feel like he's kind of just thrown a lot of those out the window. It was like, what about all those other things that you said? And you just kind of deleted them, and you haven't really addressed them at all, or anything like that. So it's just kind of bewildering to me.
that's where
Yeah,
I'm
and
at right now. Kind of just like befuddled, like, what? Wait, what?
Yeah, he hasn't addressed a single, like, any of those arguments that he brought up in the past, and now it's just tossed out the baby. Tossing out the baby with the bathwater kind of a thing. It's just, what's up? What's going on through your mind here? And so, yeah, I'm just trying to be supportive, but at the same time, actually confront what he's saying, because I feel like his arguments need to be addressed, and yeah, but we can still love him at the same time too.
Yeah, well said. And last but certainly not least, Miss Cammie Nodell. Cammie, how are you doing today, ma'am?
Oh, I'm doing good. Actually looking into the topics that we're looking at for this show tonight, kind of, and got my interest back up a little bit, and what I'm trying to get my motivation back up, because it is dealing with a lot of the things I've been dealing with, or I've tried out in the past. You'll see a miroscope is one of the things that we're demoing tonight in What Is Real. But there are things that, like, for years, with trying to look at with what we have up there, with what the properties that are up there, when you look at a combination of science readings that we take, data that we collect, and then merging that with, again, all of the old histories, the Bible, the Vedic history, the different again, you have your cosmology and so many different sources, and described so many different ways, in so many different cultures, with a lot of the same attributes. And with those attributes, if you try to introduce a few of them into it, that they have glassy, shiny, water-like fluid, the different ones, and you combine that with the scientific things that we know the magnetic field that we're looking at. We know what optical illusions they have. We know that we're looking through a fluid. We know a lot of the things that we're dealing with. We're really doing good now. We understand now how our eyes operate and how we create real images, which, by the way, what is real? A real image is something that, by the way, your eye, the way it works, creates a real image. Real images are fascinating. Tonight's show is going to contemplate the differences between virtual images and real images and properties that come with real images. And while looking at these things and contemplating with what we have in the sky, it's a way to look at the sky and possibly come up with some explanations for what we see. Now,
That's
when looking at all of this, what I do want everybody to keep in mind, because I've been doing this for, working on it for a number of years, and it's like, oh, why don't we just have this whipped and figured out, like they do in the globe Earth with the dark matter and not understanding anything. You'll notice that everything you're looking at has an enormous amount of variables that you can still get the same effect, but you can get it through moving your focal point, changing your angles and doing things. And so again, how do you design this? What optics are in fact, what things are in play? I don't know, but these pieces that are up there all are the pieces in my mind. What we already have up there is what's needed to make it work in reality. Could we completely back engineer it? There's a lot there. It's pretty genius. But looking at what's up there, you can, again, start to conceive how we could see what we see. And again, I think can kind of explain maybe what Jaren saw. It did to me because that was one of the possibilities I had, especially where Jaren went, which was if you do put our map in AE it and pop the North Pole in the center and stretch it out, you'll notice that where Jaren went was right by one of the magnetic poles. That particular part on the ring was right where he went, where he saw the circling around, and circling again is a property of magnetic fields. So the way you're going to see and the way, could project into it. So also with that, Zach, I didn't have you cue the video, but when looking at the sky and ways to perceive it, I want everybody, because I think almost everybody in our audience has seen and seen this video. And Zach, you have a T-shirt with the quote on it. Can you tell us a little bit about the quote on the Eric Dollard? What does he think the sun is?
Transformer from another dimension.
So who's
That's
Eric
what he
Dollard
thinks it
exactly?
is. He was a scientist that got to use one of the observatories to study the sun for years.
Uh-huh.
And he came to the conclusion that that thing that we see is not the physical object. It's the light reacting with our atmosphere, just like
Transformed
all the
in.
other lights up there.
Kind of reminds me of the daylight versus sunlight demonstration, where the daylight is just ionized particles in the atmosphere.
Mhm.
And that's why, because I was just looking at this the other morning,
Mhm.
actually, and I was observing the sky. I was like, wow, that's interesting how I was looking at some pink clouds out in the distance. And I was looking how it was interesting how there was these pink clouds, and then I could look underneath the pink clouds and I could see the blue sky out beyond those. I was like, it's interesting how that sky is blue beneath the pink clouds. And I was trying to think about all of the properties of light that would cause that to happen. And one of the big things was the ionization of the gas particles in the atmosphere that ends up creating the blue sky. That was done by Dimension Dan, right?
Yeah,
Dan
Dan
Dimension would be
Dimensions, all the colors of the
the.
sky it's
Mhm.
responsible for.
Yeah. I thought that was
And
just
Certain
Zach, does
ones
that dimension?
ionize further away, and that's why you see the red is the last one you see usually at sunset, because the red is the one that gas is lit up from the furthest distance from the
Yeah, that
source.
was the interesting thing, though, is because these clouds were closer to me than the sky in the distance. Okay, so we've got the light that's coming through and it's hitting these clouds, and the clouds are turning pink. And then I could look underneath the clouds and see out beyond that, and the sky was blue. I was like, that sky over there, that's closer or that's farther away than those clouds are, but those clouds are pink, And so
That
those
could
kind
be
of
scattering at the angle too of particles in the clouds and that and the light scattering. So many different things with the optics. One of the things we're going to show you tonight with optics is how you can. This one I love. When looking at light, one of the things is when you have a focal point in that in light, you can actually trap particles, physical mass, and levitate particles on a convergent point or a focal point of light. You can use the light to levitate something mass.
They've been doing this for quite some time. This isn't anything new.
But we'll look how magical focal points are and how, again, you can create images, virtual images and real images, and what's the difference and some of the properties that, carry on with it.
And I notice right here, it only creates the focal point when it's lined up. Like when it's off right here, like here's the X over here, and then this line, it's making more of a triangle right here. The only time all three of them converge is when it's right here lined up on that center line. Yeah, I've never played with concave mirrors.
I do
And
not
then
have the
convex
concave
mirrors,
Yeah.
they don't interact. They all spread from each other.
Yeah, it's hard for me to think about like focus when I'm not talking about like using a lens to get a clear picture, because this isn't quite getting a clear picture. And yeah, that's the hard part for me. And so I just see focused as in all the light converging on one spot. That's kind of the definition of focus as I see it here.
Well, that's the focal point.
Yeah,
They
because it's
call
all
that
converging right there.
of the lens. Yeah, everything converges on that one spot.
Yeah, but
So
it's
if
not
you
really
remember
about
playing
a
with the
clear picture
miroscope,
and unclear picture here.
No, if you remember playing with the miroscope, at that focal point is where an actual image, a 3D image would appear with properties that you get the actual image, and that what you are seeing there is what's known as a real image, compared to like a reflection, which is a virtual image.
Okay, that was kind of fast. You're saying that the hologram in the miroscope is the real image?
Right, that's creating something called a real image in 3D. It's taking it and converging the image onto the focal point, and you're picking up the image on the focal point, and that is a real image created, as opposed to like just a reflection in a mirror, such that you're actually getting with, again, your concave mirror. You think of it as also, I like to think of it as a parabolic dish, because really anything that you can do with the light that you're seeing on the optics, you can put into place and think of what we use parabolic dishes for. And
This
also,
definition of real
I know
image
you can
is
get.
kind of throwing me through a loop here, because when I think
I
of like a
think
real
we should go
image,
to the beginning. We should probably go to the definition in the beginning and start explaining probably a little bit better and showing you what a real image is, where it creates, how it differs from a virtual image. And again, how this could be into play very much so in the sky when we're looking at, and again, how it will invert itself and how we see the sky, how things rotate. And again, something like this could be a very big puzzle piece into it. Might not be, but it's certainly worth working into, because we have properties in the sky that definitely can, again, can cause this type of optics to occur. And again, one of the things we'll cover also on another show is like optics and optical illusions in nature, which you can think of easy ones, the Phantom Morganas, the mirages, again, quite a few different things going on. But
I
So
guess
here
what I
you go,
need,
Kyle. A real image is the collection of focus points actually made by converging, diverging rays. So it has the focus point. You're seeing a bunch of different things and it's all focused into one point. It's multiple different rays of light focused at one point, where a virtual image is more like this. You're seeing they're not focused anymore. It's like looking at a mirror.
Mhm.
that's a virtual image. You're seeing the same, you're seeing your reflection, but like if you go to the side, you're not going to be able to look around the side of that thing at all. It's not a
It feels so
collection.
backwards. It does, because what's going through my mind is the way it should be is a hologram. That's an apparent image. It's not real because it's not like you put an ice cube in your
Yeah, but this
holodeck,
is in
in your miroscope.
optics.
You put a ice cube in your miroscope. You get the illusion on top, and you think that is the not a real image, but the ice cube is the real image, and it's not the way it's defined here. And that's
Well,
Yeah,
it's an
that-
image.
that makes sense.
That ice cube is though a real image. That hologram is a real image, a true image of that
Of the
ice
ice
cube.
cube.
Yeah.
And in fact, it's
Whereas,
going
That's the
to,
mind-boggling part.
Yeah.
and it's going to, when it collects at that focal point, it's actually going to get a lot of the attributes of what it's focusing. Like again, when I put a piece of tinfoil in my miroscope, which was again your mirrored concave double dish, and I put that piece of foil in it and I collected sunlight on it, I about blinded myself with the hologram. I mean, it was that I have created shadows.
Uh-huh.
You know, again, you can with the light off of it. I have again, we've done a lot of things with the miroscope, which is a real image. You can shine light and actually bounce light off of the real image without touching the real object. But the real image is somehow, you know, again with the focal point, it connects itself to it. It starts to take on some physical properties. I don't know how else you could think of it any differently. I mean, they talk in their physics about the protons and that when you accelerate those protons, that energy is creating mass or equivalent. Again, they're going to take it into it, which again, we understand light is a perturbation in the wave. But somehow when you perturbate the waves with the light and connect them at that focal point, you can actually create that image. You can hold properties and you can actually levitate things at that spot. In other words, things will naturally want to trap and levitate there. If you have something small enough and with the right properties, you can actually float things in where the light converges.
So yeah, it's like a real image is like a reflected image with additional properties to it because of the amount of reflection that's
And
able to focus in that one point.
yeah,
we're going to, in a lot of these
focal
videos,
points, a
play it
bunch of
in is
different
all
focal
to
points.
do with where your focal point is going to be where it is how does it make it? Are you seeing it at the focal point? We're going to, your questions are, we're going to, it's kind of elusive, so we're going to take you a little bit deeper into it because there is information on it, or we have fun things that are going to explain better than me just talking. I think we've got the visuals, what works for me.
Yeah.
Yeah, I love this one right here.
And this kind of
A
image is
concave
different
mirror.
from a photo.
Yeah.
Okay.
So this is an image formation by concave mirror. What they have here is a little mirror holder. They have their concave mirror placed right here. And then he's going to have a light source and a little screen. You'll see it. And it's going to show you the different things you can do with it. So case one is the object is, oops, let's go back that real quick. Object is very far, i.e. can be considered at infinity. So
That's kind of weird for me to describe it as at infinity because we know that light doesn't travel on forever, like because we got the inverse square law of light that causes it to dim over time. So the infinity part doesn't quite make sense to me.
yeah, that's just what they
Well,
said.
in other words, I think it goes outside of the with the infinity, and that a lot of it has to be with, which we'll go into other videos where it shows you how you can measure where your focal point is, and it's marked on lenses, which again, this is fun because Karen and I actually have a lot of different concave and convex lenses marked with their focal points on it. So things that we can play with the light and photograph. But infinity is again for photography and everything. I think it's like the outside of the room, outside of the focal point area.
Oh, okay. Yeah, like infinite focus thing.
Mhm.
Yeah. I've
So you
heard
have
of
your
photography term. Okay.
light source way back here. It's bouncing off of the concave mirror and projecting onto this sheet up here. So you're seeing the flame right here. And when they turn the light off, it's amazing how much you don't see. It looks like there's just a flame dancing right here. A lot of magicians have used this kind of stuff for well over 100 years. And look at that. you have a floating flame just in the middle of the air right there, it appears.
Oh man, this would be cool to show my kids to try this out at home to try and make a ghost image of ourselves up here
Yeah,
on the
it's
wall.
real simple to do. The hardest part is just finding the concave mirror,
Yeah.
which isn't super hard to do.
Oh yeah.
So now they're going to show you what's taking place here. Now we have object just beyond the C marking right here, and it's much bigger since it's a lot closer.
The
And
ghost
that one,
form.
yeah, it's just you can kind of see it because the flame is so close to this thing. But yeah, you have some kind of projection screen up there, something to bounce it off of. And you can do all kinds of cool stuff from the ground.
So hypothetically, what we could do is if we have the right kind of like concave dish, we could shine a light into the dish and get it to project onto a cloud.
Or depending on what's up there and how strong of a thing, how big of a thing you have, who knows what you could project onto whatever's. I know there's a sodium. Is it a sodium layer that's up there?
We have a sodium layer, we have a magnetic field, we have several different things. And again, you're going to find out in other things with the real images. Again, if you do this, you won't need a screen to project on. Even they will create themselves in open air. So it's not like you need the screen. The screen is going to be part of the test if it's a real image or not, if it will produce on the screen, because if it's not a real image, you will not be able to get it on the screen. So this is more of a test to, again, to pick up on the focal point. But again, if you do it, you can also, well, in this one, you'll see with the other. Keep going.
You'll notice it's about the same size now.
Is it upside down?
Yes, it should be inverted.
Okay. It's kind of reminding me of there's
spoon or your eyeball, or again, how they before corrected, and again, going back and forth. If you think about
it's reminding me of a pinhole projector. That's what it's reminding me of.
And now once you move your screen back, now it's even bigger. It'll be bigger than the actual image.
Yeah, you're magnifying it.
So look at that.
This reminds me of
Like,
the Mummy.
If there were something... Oh, go ahead.
The Mummy, how they lit up the entire room by using mirrors. Kind of reminds me of that. I think they used concave mirrors, if I recall correctly, when they did that.
So this isn't going to change position depending on our position, right? It'll always stay right there, projecting onto that. No matter where you are in the room back here moving around, this isn't going to move. Upside down, that's wild. Yeah, concave mirrors are neat. Size enlarge. Object at F. Now it's going to go way up high in the sky when it's far back.
That'd be interesting. All of a sudden it starts on fire or something. The fire attributes gets applied to the paper, you know. I think it's not perfectly focused in this case. It's doing a good job of doing some of it, but not all of it. And so that was kind of what you're showing before. It was how there's that sweet spot where it's like a perfect convergence of all of the points. But yeah, this one I don't think is quite that perfect convergence.
But you'll
No
notice that
images
as you get
window.
there and move the different things, how close, how no, again, how you'll get things, and again, depending on where you do it, there you've got a lot of variables on how big it gets, how tighten that again on the where it will reconverge on it. So here's your virtual image can be seen inside the mirror, but cannot be obtained on a screen. So a virtual image you can see it in the mirror, but you cannot get it to reproduce on a screen.
Mhm.
So when you move it in too close, you can no longer project. You can no longer project. You can see it, but you can no longer project it. Kind of like you were showing me stuff earlier, Kyle, about the eucalyptus stone, which
Uh-huh.
Karen, is the TV stone where you put the
Mm-hmm.
crystal on it, and whatever's underneath the crystal looks like it's on top of it. It kind of
Mm-hmm.
projects it right up there. This is projecting the light, not reflecting it, but projecting it. So
Little Lego guy there. Got a
this is cool.
big concave mirror.
And where does the real image form? Here, it's going to show you.
Now they have those. I know you can order for security, like the corners of hallways and stuff. They'll put them up in like hospitals and places like that. I wonder how much they would be.
I don't know. I would like to look into it. And again, my dream is at some point to get some of these pieces in a metal for conducting purposes, or even, again, finish at the end, because again, with the parabolic function and that, we get the optics really good with the mirror, but I want to get more properties, and the more we culminate the material, the better. If you guys remember like different things I've done where material makes a difference, where I've taken an ice cube, Zach, this would be Zachary Karen, or that I've had you do the ice cube and hold it to the diamond and see how you can cut through it with your finger on the diamond using it, and it just melts through. Like that's the culmination of the diamond and how it's getting its property and working with you and augmenting what's going on, melting it a lot faster than if you were to just touch it with your finger. Or again, it's crazy.
So this is a really warped image that we're looking at here, and
Mhm.
that's a virtual image because all of the light,
But
the light
it's
is
out there in front upside down. In other words, it's he's putting his finger through the image. It's not a mirror. It's an image. Like the mirror
Oh,
is back there.
I'm gonna find. I got a video that's perfect.
Now we've
for
got a
that.
bunch of mirror scopes. Now, when we get into the mirror scope one of the things that I have not done over the years, because I used to play with this a lot, and again, it's been more than a minute since I've had a good confident mirror scope. They used to sell them at Think Geek and many other places, and now what's available is complete garbage that comes warped and like with the thinnest coating ever. So anybody seeing these good mirrored parabolic dishes, if anybody's got a good heads up for me, let me
okay.
know.
I think I
But
understand what you're talking about now.
Mhm.
You're saying that this is having a mirror scope effect where the little
Mhm.
Lego person is appearing to be like right next to you, but it's
Mhm.
not. And so that's why you're putting your finger up there trying to like touch where your eyes perceive it as being, but it's not actually there.
Oh,
Okay.
Kutzpanias, perfect. This is doing it through a lens. This is great.
Now that's an image of a star on the wall back behind us.
That's
Mhm.
me
And
with
it
my
looks like it's just floating, like he's putting his hand right through it.
right through it. And I am gaping there. I am loving this. How big a mirror scope do you want, Cami? I would love any. I mean, having it like at least 8 or 9 inches would be great to work with. If it's bigger than that, that's a bonus. I'm looking at the chat and having dreams and that, because again, this is starting to get some motivation. I do have different lenses and things that we can put things through. Got that in smaller working order. Even if it was smaller, I think it's more important to have it competent, like a good quality, than size. I would like
This is a good way to win the science fair, right?
mhm. And the other thing is I almost want multiples, because though I can do this one with my little dishes, I want to unbury them and get them out and do a hologram of a hologram, or a mirage of a mirage, or however you want to do it. If you
That'd
think
be
of where you
wild.
place something on the dish and where it makes the focal point, if I did an open bottom dish underneath that and another closed one, I'm wondering how competent of an image I could get of a focal point real image. So that's something I have not done before, and I've done a lot of things. That's not one of them, and I'm not quite sure why it never occurred to me before.
Yeah, this is
But
getting me
doing the
thinking.
series, because if you did that, if you did it in series, think about it. One of the things when you do this, it does it like your eyes. So if you had a frog, I think you guys see me, and its eyes are pointing this way. When you see it a layer up, it's up here and it's pointing this way. So I think that the sunspots in the way they turn, flipping it. And if you flip it another layer, up again, it's going to move it back over. In other words, each layer is going to re-flip direction a bit, like your eye would, or in a spoon, invert it. But again, you have these different properties that, how could you see the sun working the way it does and doing it? Some of these properties would work.
I think the wild part is like the where the light is. Like you think you need a screen or something for the light to reflect off of, and you kind of do, but are you looking at the screen that's making it appear there, or is it like actually appearing right there in front of you or something like that? You know what I mean? Because the light's kind of focusing. That's the focal point right there.
Mhm.
Yeah, and so it's like illuminating the air right there. What's being illuminated is my question.
This I've done a lot of playing with, and again, you're going to pull it down from there. When you saw the double imaging of it, when you put it there and you see it sitting on top of itself, if you don't mirror where it's sitting on top of, you're going to pick it up without the mirror. In other words, this works fine with a hole in the bottom because it's picking up the object, and with that, it's picking up the mirror bottom too to make it part of it.
So
I've
for
had fun
everyone
doing it
else
with
who's
open and water and that. Now see what they're doing here? No, I'm wondering if I set another open one at the bottom and look at it and capture where that focal point is getting together. Can I
So
take it
for
and
everyone
send
new
it
to this
another level?
conversation, this device here, this is called the miroscope. This is what we're referring to as the miroscope effect. This double dish, and you're getting this focused image right there on top. And again, my question is, what exactly is being illuminated here? What are we seeing this on? Like, is this like, I don't know,
This is
it's kind of like,
appearing out there. So Conley in the chat is saying, so is the sun, moon, and stars within the firmament or on the firmament or that? This is something I'm open to. The firmament, which is considered a vault and open expanse of that. I'm not so sure it's just a lid or like a pot lid or something like that, or a dome over the top. I'm not so sure that the firmament, or again, you'd have your first heaven, your second heaven. I'm not so sure that with all of the descriptions I've read everywhere that it's not an expanse or not a containment or that, compared to just a lid to just a ceiling. Most people interpret the firmament as being a ceiling to our world, just a ceiling. But again, if you look at the word expanse put in it, with an expanse and the word vault in that, to me, it would make more sense that firmament or this vault would be a vault of looking glass. That's what you have here, is a vault of looking glass. And your vault of looking glass creates a real image. It's
yeah,
again, it's not far-fetched. I don't know if that's the answer, but I open it up as a possible puzzle piece, as a direct possibility. We can do it without the vault. We can also do it just with single lenses. You can again do different domes and things like this, but it opens up a lot if you add a full layer.
and that's what I really appreciate about the star that you showed before is you don't have to have the double cup effect in order to have that take place. You just showed that with the star in the background with just one kind
Right,
of
one lens.
one dome.
Yes.
Yeah. However, it's still out behind it, behind you. And so if that were to take place on Earth, then that would make the stars somewhere here on Earth. And it's a kind of
Right.
reflection, kind of shooting it up into the sky.
That's exactly
And
what it
that
would.
part
Yeah.
doesn't quite work with me. I'm not quite convinced. I'm definitely not convinced that the sun is underneath the Earth or something like that. I'm not
Kyle,
there yet.
Kyle, no, that's where I was caught up on it, is that in order to project over the whole area of the sky, you would need again, but again, then I look and say, do I really understand? Again, if you did it tight, like again from the North Pole, do I really understand enough to say to rule it out? But the
Yeah.
physics work much easier if you have a big aperture over us that you can project down to, because we know that we do not have a big aperture. What we would have would be like what would be under the North Pole, but compared to the amount of the land, it's not, you couldn't, if you put your miroscope or your aperture in the sky, you could have an aperture easily running
I
between
can
the top to
I
the
can
tropics
visualize
would make
this.
sense.
I can
Yeah,
visualize this
an eye in the
horizontally.
sky. Yeah, think of an eye in the sky, and it would be easy
Yeah.
to say that you could have the aperture and an opening the entire distance of the tropics, or do that where, again, you would limit it by having it on the Earth and going up that way. But again,
Yeah.
these are just ways that we're learning on the physics. I certainly
So
have so much to learn, but again, this gets some funness going on it.
I can visualize the actual sun being in the firmament and then getting holograms of that sun displayed in different places, and being reflections, or having focal points. And so you could have the appearance of multiple suns, and that would be mirror images of each other inverted right here, literally, and just because of the way it gets reflected through the sky.
Have you ever seen this?
This, if anybody's played with a kaleidoscope, you kind of know about it, but now you're going to see how it works right now.
The
This is simply
smaller
a
the angle,
folder
the more
images you're going to get.
images you're going to see of that one single
So we have
image.
3. So as you tighten, and again, where they tighten it and hold it is on your kaleidoscope, how many different sections and ways that it goes into it. Just simple like that. Just like that.
I think that's really wild with just 2 mirrors getting all of those reflections just with those 2 mirrors alone. That is just,
That's a great one for your children, because it goes from, again, all of the way around to, again, starting with, again,
Now, I think the issue with a reflected sun is I would expect the same thing with the stars, but there's only one Southern Cross. I'm not seeing tons of different reflections of Southern Crosses, maybe in different locations and like in the South, but I'm not seeing the Northern stars reflected into the Southern sky. And so if I can't get the Northern stars reflected in the Southern sky, why should I be able to expect to see the sun in the North reflected in the South? Kind of a concept. You know what I mean?
projected works better than reflected. Projected, again, the idea of having a projected into it, especially with the sun and the moon, works a lot better, because again, projected comes with properties that we observe,
it's
that we
still
can measure,
matching.
that we can feel.
It's still a matching picture, though. There's the actual thing, and then there's the picture of the thing, and so it's kind of a replication. And so, in order for that to happen, I wouldn't expect it to just happen with the sun, but I'd expect other things in the sky to also be reflected.
Oh, I didn't see this one,
Or
Zach. Did I send you this one? Because I
mirrored.
don't know about the magical soda cans.
Well, no, this has to do with the optical tweezers.
Oh, okay.
So he's going to create a pressure mediation right in between here by moving the air faster between this small space, which means the pressure is going to be lower right there, and the cans are going to be forced together. Even though there's nothing on the outside of the cans pushing them in, they're going to be dragged in from the center.
Kind of a vacuum effect.
Yeah, this is Bernoulli's principle, right?
Mm-hmm.
Yeah. Then he'll show it to you slowed down here real quick. And as he blows, you can see the cans want to come together. There's less pressure in there, more pressure on the outside. Pressure wants to mediate, so it pushes the cans together.
There's another video with balloons that they did it, and I think it was a little easier to see. I don't know if you got that one.
But that's how they came up with this idea of optical tweezers, they call them. It's using a single beam of light, a laser that has a focal point. So the laser is designed to or it's run through a lens to where it converges the laser at a certain point. So the laser is going to, it's usually going out straight like this, and then they're going to put a lens right here, and then all of a sudden it's going to tip it in to where it's going to be at a sharp point and cross. It'll actually look like that, a big cross. Well, just like those two cans with the air flowing through it, now I haven't done this yet. I'd really like to try it, but
I sent you
it appears
a
to
video
work.
too. Yeah, I sent you another
Um,
video too on it in the tech chat afterwards,
okay.
after you posted it. Because I know that like what the optical tweezers do and show in a lot of them when they're doing it is you'll take it and a lot of the times you'll use 3 beams and converge it, or you use a single beam and then use lenses to break it up and reconverge it. But where it makes that focal point, again, very much like what we're showing you on everything else, where the focal point is and where it comes together and converges. If you blow smoke or things into it, you can see where this area is. And as soon as you pinpoint this area, which is your focal point, you can actually drip matter, put little balls or do things on it. It's a levitation. You can levitate matter. So here's going to show it with the
They
red
call it
laser.
optical trapping. So you have your laser beam, and then he has a lens on here that's creating a focal point right in here. Now he took a marker. That's what a lot of people use. They'll use the tip of a marker, and it kind of
Melt it in the
burns.
ladder.
Yeah, it just melts a little bit of the marker off there, and you can actually get it to hover right
So this
here.
is the kind of laser that can burn things.
Right. So
Yeah.
a laser beam, you converge it, it does that. And again, if you set a little tip where in the focal point where it burns, you can get things to levitate in that spot, which again, they're going to explain it on like water and that doing it on a ball, which I'm going to say, because we're not working with particles, it's more of a nodal point in the perturbations. But we do have something there at that space where light converges that you can trap particles and trap matter. And I think that's pretty amazing,
Now
called
he's going to
optical
move it. Look,
tweezers. It's
now
going
he's
to move
changing
it.
the focal point.
Mhm.
So it's moving. It's actually not just holding it there. He can actually
You can move it,
move
matter.
matter, this little tiny particle, that burned off the tip of that marker.
It's right there.
So right here, I just get the words "light is a wave" just echoing through my mind. Light is a
Right,
wave, and
that's
so you've got
correct. Keep that echoing.
particles that are suspended in the wave.
Mm-hmm.
And
There,
light
yes, they
actually
are. So that would
creates
be at
a
a
pressure
nodal point.
mediation.
It makes the pressure mediation right there. It makes the nodal point at the
But the hard part of
perturbation.
lasers, I
That's
don't really
ether.
like. Lasers are generally described as like photon-like. They're not really described like waves.
Right. But like it's a wave, and this would almost be a again perturbation ether. This would be fun to talk to with Alan. This would be really fun to
Wow.
talk to
So
with
this
Alan and
one,
Shane.
it looks like, I bet the beam crosses, say, like, if you could actually see the beam and we zoomed in, I bet the beam crosses like right like that. I bet the cross is right here. It looks like they've trapped a particle on each side of it almost. Is that what's going on there?
That could be what's going on.
That didn't look like just one.
And you see in the things too on the lines where you'll have different on some of the crossings where again you'll have different subfocal points in that crossing over where you see you'll get a weekend.
This kind of makes
Maybe
me think
not.
of the Starlink satellites. How they have this trail of satellites that moves really fast in the sky.
Mm-hmm.
And yeah, I'm like, huh.
Now this one kind of blew my mind. They say this is a electron microscope, and what you're seeing is them using optical tweezers to grab little tiny particles into bunches.
Which is weird because you're not seeing like the laser light itself. You're just kind of watching this little clump just seem to move on its own.
Yeah. I don't know if I don't see a crosshair or anything.
Well, they're saying, I mean, one of the things they said is for magic tricks and different things like that, you can do this with a laser. You can't see it will work just as well. And with the visible ones, again, on any of the ones you blow smoke or put a haze on there, you can definitely see what's going on more. Well, again, you can mark your focal point and that really easily.
I've heard of people doing similar things with sound, and it just kind of light and sound. They're both parts of the electromagnetic spectrum, right? And so
Hmm.
you should be able to do similar things with light as you do with sound. And I think
Hmm.
that's kind of what's going on.
Yeah. Yeah, I just thought that was really neat. I had no idea about this until Cami showed this to me. Because I always wondered, like in the particle accelerators, how do they get the particle to just hover there in the middle before they start accelerating it? You know, do you drop it in and hope that it? But they're using very teeny tiny things, and they would get it in there with stuff like this. They'll have a
And that was,
laser,
yeah.
you know, that creates a tunnel almost all the way around the thing for it to travel on, and then they
And as you're
accelerate.
watching it, when they do it and they accelerate it, what's cute about it is what are they doing? They're using a whole bunch of little quadruples. You look at the magnetic sensors they're using, and they are quadruples in series, and that they're using to accelerate light on a lot of the experiments they're doing in laboratory on this. So when they're running those ones, I think it's kind of great too. That takes us into a whole other series that I didn't queue up for tonight.
But yeah, this is just some different ideas on, you know, pieces to the puzzle. Yeah,
Yeah.
are they used pieces? I don't know. But if they are and you don't have them, you're never going to put the puzzle together. So that's just what this today's episode was about. Was kind of, you know, sharing some things that we found on how things up there might be projected up there or might be
They get
held
me
up
thinking
there.
about Operation Bluebeam and different ways they can fake aliens.
Yeah. Yeah. Yeah, I've been, you know, I have one of those conspiracy minds. I see a lot of things going on here in the United States government right now, and I see a lot of people that are like, yeah, it's finally happening, this and that, you know, we're finally, and I'm more like, okay, these people aren't, you know, it's not like they're, I'm not saying they knew about it, you know, people that have been being very corrupt in the government. But to me, this was all planned, that this was all going to be found out and caught. And that, you know, everything that Trump's doing wasn't Trump's idea to me. To me, the way I see it, this, what, you know, it's all a stage. This is a show. And the people on stage that you're watching on your show do not write what they say.
They're just following the script.
They're just following a script. Somebody else comes up with the ideas and writes them down and tells them what to say. So knowingly or not, you know, it's just baffling to me what they're doing. Why is this? Why are there so many truths coming out right now?
Yeah. I think one thing that really stands out to me also is the clay and the iron, and Nebuchadnezzar's vision with the statue with the feet, and how the clay and the iron try to work together, but they're not perfectly in line. And so there is still some friction between the different powers that be right now. They're not perfectly unified. And that's why I want to evidence for that. I just look at the Chinese footage, their space footage versus the United States space footage. And that tells me that the world is not, the powers that be in the world are not perfectly unified. There's still some friction between the two of them. It's not one unified picture.
Now,
Yeah,
on the optical tweezers that we're talking about, because this isn't, we're looking, it looks like it's optical tweezers, but this is this is this is the mirror scope for creating a mirage, you know, getting used in the mirrors. People don't like when I call it a hologram because it's not, but it's just hard to change the language on it. It is, it's a real image is what it is. But on the optical tweezers, if people wanted to see a little bit more what's going on, though I don't like the verbiage with it a lot because they talk a lot about the photons and how it happens. And this Action Lab does do a good video on it, and you can search Action Lab and optical tweezers. What he does do on his that other people are not doing is he's doing like the three laser setups and blowing smoke where you can see the focal point before dropping it into the things, and that's kind of fun. So if you wanted to like visualize it a little bit better, see how it's working and sitting into the spot, and before and after, and where Zach said there might have been two of them sitting there because that shows the two places where it'd be fun to do. We are not going to show because every time we do, our videos get taken down. Action Lab does not like us.
No. Yeah, he does have a great video on the subject. He breaks it down really well, but I don't even like showing 10 seconds of his videos because we get struck like every
Yeah,
time.
there's too much grief between that. Yeah.
Aaron, how are you doing? You're quiet. Are we putting you to sleep on this, or with the optics, or do you have any thoughts on different
She's
things you've
just
seen with
bad.
optics? Or
It's been a long week.
it's been a long week.
I mean, I watched all these videos earlier today, and I've seen a lot of it before. I'm just,
Mhm.
I don't know.
It's nothing new for her, really. We've demoed
Right.
a lot of it and done that. Yeah.
Yeah.
Yeah, some of this is going back, 8 years now? We saw some of
Yeah.
this stuff.
Right.
We've
Yeah.
talked about this a couple times.
But
Yeah.
it's nice to have these refreshers, There's
Hmm.
new people that come in. Some people haven't seen a lot of this stuff or may have forgotten it. I love that when I see something that I used to know really well, like dug into, and then I come across it again and it almost surprises me, like, whoa, I totally forgot about that.
Hmm.
It's been happening a lot lately with
Yeah.
flat earth stuff that I see people bringing back around again.
I think with this, you couldn't get the image in the sky unless there was light coming up from below, and that's something that would have to happen. And so if anything were to come up and block it, all of a sudden you're going to get reflected light on that thing coming up.
Or think of this right here, upside down,
Mm-hmm.
Yeah,
with
that'd be
water inside of it, with a bunch of stuff floating in there. And then
Mhm.
it would project it not just right up there against the screen, but you could have it all spread out
Yeah.
in a
Yeah.
bigger, the hole could only be this big, but the projection could be as big as the actual apparatus, the whole domed
Yeah.
vault.
That would work, but in order to get the image to move, it would seem you'd have to move the entire thing around. And that's the hard thing for me to
Well, yeah,
fathom.
if it
What
was
do you mean?
floating in water, you just churn the water.
Turn the
Oh,
water?
okay.
It
Yeah.
would all,
Mm-hmm.
it would all
Yeah.
just sit there and spin.
Mm-hmm. And I have
Yeah.
done water in these. Water works really well in them. I've also I've done like the paperweight glass domes where you put them over the top of this. If you do that and started introducing domes and things like that, they propagate like in the middle of the dome. They're no longer sitting on top there. They will go further into the glass. They'll jump different places depending on what lenses I put in between. I put different lenses between the mirror scope and the air, and the images go through anything. I mean, I was using where I was putting like a lit up little, glow in the dark ball where because I was hitting the hologram and lighting them up, but I was using a Pyrex bowl over the top and getting it to go through where it said Pyrex, and the terrible Pyrex writing, and it was going through the writing and everything on the bottom of a bowl and projecting itself up into the bowl that way. Even it's amazing how, like, again, it will project and do, and again, the different things have an effect on it, and yet it seems to go.
Yeah. I'm just wishing I could craft my own kind of image like this and see how far I could project it out, kind of play with that around a little bit. I have to think about the mechanics behind that and what it would take to craft my own lens. Yeah, because right here,
I can tell you that again, when you have the tighter convexity here that they're having and doing it, the tighter it is, it moves it down and closer to you. And when you spread it out, it moves your focal point out. And you can kind of like as you visualize it and doing it. So that's what I mean is your variables on where your focal point is going to be is how tight, how tight is that?
yeah,
And it will move it down into it again with the tight, and it'll pop it back out with the shallow. So that'd be a neat one right there to have them show it and actually straightening it out and watching the movement instead of just flipping it around. But do we have any questions from anybody?
Have you tried magnets? I'm not sure
I
if that
have
one.
tried different magnets and that, and I'd like to do some more with it. I would like to do some more magnets.
Reflecting magnetic fields? I've never considered that.
I was trying to see if I could get them to and trying to pick up the different things. I didn't have very much success with it, but I want to change my medium a little bit on it. I had some different things. I was trying to see even if I put a magnet in it, could I get the reflection, you know, how much. I'd like to test a little bit more.
I've never, yeah, I guess a magnetic
But
field,
we
that
were
would
doing
be
all kinds of
part of
different things with it.
electromagnetic spectrum, right? And so if you
Mhm.
can reflect light,
Mhm.
why couldn't you reflect a magnetic field? That
That's
kind
the
of
whole
makes
thing is with the parabolic dish, you use them to reflect radio waves, all of the waves, the entire electromagnetic spectrum.
yeah, you
So
can
just
reflect
because,
microwaves. So
exactly, your microwaves, the whole bit. So we
yeah,
think of the optics as what we see, but when you're doing a what I'm calling a hologram, even though it's not, but when you're doing a mirage through this type of action, where again you're doing it via focal point, and again especially when you do the double mirrors like on the mirror scope and really augment it like that. Forgot where
Are
I was going.
magnetic waves the same as? Are they on the light spectrum? Or are they a different type of?
They're different types of action. They've got their own. That I was just trying the action with it, but I don't think I think they're more perturbations,
Yeah, it was
or
just, it's
they
more like a
interact with the
breakdown.
perturbation. Yeah.
Yeah,
But
I'm
I
gonna have
do
to
know that
think
I
about
was
that
checking
one.
for some of the different things, and I forgot where I got distracted. I know I wanted right now. I was thinking I never did stack them, but we were doing a lot. Again, we were doing a lot of them, and I wore out the dishes, and I don't have good competent dishes anymore because again, the ones that you get that are like $14.99 that used to be $6.99, the 6-inch ones. If I open up and showed it, it looks like they're wrinkled foil on the inside now. I mean, they are coming.
Hmm.
okay, so
They're
I think what Randy is asking is, have you tried putting a magnet inside of the mirror scope? And
yes.
so you put a magnet in there, kind of like an ice cube, and all of a sudden you get this weird thing up top with magnetic properties.
Right, but I wasn't. I mean, I did that, and then I was holding metal. I didn't bring equipment or anything. I was just trying to see if I could get something to stick to it or that. No, I did not get the strong sticky action. So yeah, I did put a magnet in there, and I did test that. I'm not going to that by doing that. I did not get the heavy ferro stickiness. In other words, I
Interesting.
definitely.
Yeah.
So I was seeing what works, what doesn't work, and because the magnet is producing its own field, I don't know. Again, if I put something hot in it, the hologram heat transferred and cold transferred. I thought that was very interesting that if you put a piece of ice in it, the hologram of the ice was remarkably colder than the air around it where the hologram was.
And I've never even thought of putting a magnet inside. I'm like, wow, these
Mm.
people are thinkers. I'm surprised you thought about that way
Put
back
more
then.
things on there because I
Yeah,
can't believe I didn't think of stacking them and seeing if I could get the hologram to again flip again by doing another layer, hologram and a hologram, to see if I could again make an image of the focal point image. So that one
yeah.
I'll try. If anybody else has put messages in there on things to do, I'm going to look. I've got some Meriscope dishes. They're very, very poor quality, but again, with the poor quality, you can at least get a echo of what you could expect to get with something of better quality.
Yeah.
You can check the feasibility. You certainly won't be able to test the magnetic strength or any of the, fine functions of it. But, and I think where we were going with the other things that I dropped off was, again, with the parabolic dishes, you transfer all type of waves that way. Again, it augments, it focuses, it's a well-known technology.
So to extend the range on the real image, the focused light, the focal point, is
Hmm.
you could take the concave
Hmm.
mirror, and so it kind of spreads it out further, and then you just got to take those reflected images, the reflected light, and then just refocus it back into that one point, and then it get out farther away than it would have originally happened.
I think so. I'm not quite sure, but I think I understood what you said. If you
Yeah.
wanted it to pop out, I did know that, like, again, the again, how shallow or steep your angles are is going to change your focal point. You can look at the pattern and see how it would do that. Again, as you straighten it out, it's going to move the focal point out just by the nature of the physics. Again, if your blue line inside where the line showed up in that, but don't know if I answered that one well. People do have good questions, so.
So cool. Well, alrighty, folks. I think that's going to do it for this evening show. Will there be a scripture study this Saturday, Karen? Do you know?
Yeah, I think
I know
so.
last Saturday you guys kind of threw me for a loop. You didn't start till way later, and I missed it. I had to go back and watch it.
Yeah, that was Jack.
It happens.
But yeah, it does happen. But yeah, we should be. We're almost done. I think we only have a couple more chapters of the Torah.
Nice. That's amazing.
Mm-hmm.
Awesome sauce. And I'm sure there'll be a coffee talk on Monday.
Should be, yeah.
Should be, yeah. I love coffee talk. Cammy's always ready to go for Monday. She wakes up, she's like, Karen will be on soon. Let's go. Kyle, what do you have coming up this week, man?
Well, I've got more to present against Jaren. He's got made a lot of points there. I'm going to confront those. But before I get around to confronting those, I've got another big thing that I got to confront, which is about how the sun sometimes appears to shrink on the horizon, but it doesn't always do that. And how the moon, I've never, ever seen the moon appear to shrink on the horizon. So I've got to confront all that and explain why the sun sometimes appears to shrink, but not always. And why, yeah, and why the moon, as far as I can tell, never appears to shrink on the horizon. And so I'm going to address that, and then I'm going to come back, because I think just getting that out of the way is going to make it a lot easier to address some of Jaren's other points. And then I've got this other thing in the workshop that it's been kind of in my workshop for years, and I just got to get it out, which is talking about the Onondagan creation story and how it's so similar to the Hebrew creation story. And so that's one that it's been in my workshop for too long, and I just got to get it out there before I continue on. But, yeah, so one thing after another. But yeah, so I've got a lot in the works to go. Looking forward to getting it out though.
And Cammy.
Well, Kyle, let me know when you do your creation story what they have, and I always like to collect it if you have whatever descriptions they have of the realm, descriptors they might put in there on the creation story. I like collecting the different ones to go along. I
Yeah.
have going outside when it gets a little bit warmer, walking the river, looking. This is a good time of the year to look for ruins in that, because the greenery is not back, the snakes are not active, and like, so being around the waterways and that, I've been kind of looking at different areas on Google Earth that look like they have some different ruins. We have that dam behind our house, and we're in an area that's got a lot of stone and that from the 1800s, and the wars and that, so it's kind of fun to see the different torn down places and that, or the old architecture, that they put through here, so it's real pretty. I'd like to do some of that, get outside, do some things,
Yeah,
get
sounds
motivated
good.
more, and again, get motivated to do more on the optics, because again, this has been the optics of what's up there in the sky and how they work, I think, hold so many answers. And so I'd like to focus more on that. There's a lot to study.
Absolutely. Well, tomorrow there will be no Iron Realm Ironworks in the morning, no Iron Realm in the evening. Josh had eye surgery today, again, on his other eye. Everything went well. So we'll probably be back at it Monday, and I will be back for GLOBEBUSTERS on Sunday.
Looking forward to that. You guys have been doing an amazing show on Sundays. I really like the new crew members, and yeah,
they're sharp.
Yeah.
Yeah. But all right, folks, you guys have a great rest of your weekend, all that kind of good stuff. Remember, be good to each other. Don't lie to each other. Open your mind, because there's truth inside. Peace out, everyone.
Peace.
Peace.